Thank you, Professor Akbari, for joining today in our podcast. We are so grateful to have you. I know it's a little podcast, and I know you're super busy and have a lot of responsibilities. So thank you so very much for joining us. Please tell us a little bit about yourself to start off with, so that everybody can be acquainted and who you are and what you're doing.
Well, thank you very much, Shirish, for inviting me. This is a great podcast, actually. And when I was looking at some of the videos, it was amazing. A great job. So I'm currently an associate professor at the University of Victoria. And for those who don't know where University of Victoria is, we are on the southwestern part of Canada. We are located in an island, which is called Vancouver Island. It's a beautiful island with lots of hiking trails and beautiful gardens. You can see in my fake background, this is a UV campus. And then, but also some people may not know, but Victoria itself is the capital of British Columbia, one of the provinces in Canada, the western province in Canada. So we make all the decisions for British Columbians there. So besides this affiliation, I'm also affiliated with, as an adjunct professor with the School of Biomedical Engineering at the University of British Columbia, as well as a couple of affiliations with Terasaki Institute for Biomedical Innovations in the US, and also a university in Poland. So this is my academic hat that I'm wearing for almost 7.5 years. But besides that, I'm also wearing an entrepreneur hat. So I am the chief scientific officer at 4M Biotech, which is a Victoria-based company, a startup that develops smart wound dressings for treating chronic wounds. I'm also on the advisory board of another startup from my lab, which is called Aprisol Biotech, which develops next generation in vitro disease models for cancer, for developing drug discovery and drug screening for cancer therapy. There is another also company which will start from my lab very soon, and then I will be the co-founder of that, and then we'll focus on developing these multi-material handheld bioprinters for regenerative medicine. So this is what I do right now. But before I joined University of Victoria, I spent 2.5 years at Harvard Medical School as a postdoctoral fellow, and I was working in one of the pioneering groups in the field of tissue engineering and biomaterials, a group of Dr. Ali Kadem Husseini, and who is Bob Langer's academic son. Bob Langer is the most cited engineer in history. I think you know him. So I'm his grandson. And I did a PhD before that at Simon Fraser University, which is in Vancouver. And a master's degree and bachelor's degree from Sharif University of Technology, which is in Iran.
Thank you for that. That's an amazing a journey that you've kind of crossed different continents. You've different parts of the world and from the United States and Canada, and it has we'll definitely get into all those parts. So So you mentioned that, just to go back to the beginning, so you mentioned that you did your master's and undergraduate in Iran. So I suspect that you grew up in Iran, is that right?
That's correct. So I was born and grew up in Iran. So I was born in Isfahan, which is a city that is located in the center of Iran, and it's well known for its for buildings which are fairly old from long times ago, and then also for its very tasty sweets.
Absolutely, yeah. I know what you mean. Since you were little, you were interested in science and engineering. How did that come about?
So I was always interested in both science and engineering. The main reason is, I mean, the main credit goes to my parents. My mother, who was a grade 5 teacher, elementary school, and then also my father, who was an engineer, but one of those curious engineers who decide who build things, and then who never relies on others to fix stuff at home. So he was always taking me and my brother to like to for example shops to buy tools and then come home and then build new things. And my mother was helping me and introducing me to different aspects of science. So I think I was originally inspired by them to become interested in science and engineering, and that's probably why I do research in biomedical engineering, which is at the
Right.
intersection of both science and then engineering. And so I know a little bit of each, and then I like both of them actually.
So your family background really kind of, paved the way for you to be, interested in science, and, you've, you kind of was interested in science since a very young age, which is, I think, is a common theme for a lot of the people that we have interviewed, that people, there is this a common background that, a common theme, which is, the parents, or there's like a teacher or somebody like that who kind of inspires these kids to become interested in the respective fields. And most of the people who have done science and engineering, they always say it was either my parents or this teacher who was amazing, or really inspirational, which really made me want to get into it, right? So I think it's a quite an important point for the role that our teachers especially play in our kids, right? Kids' lives, right? So you've kind of moved into the science and engineering field, and you did your undergraduate and master's in Iran, and then you decided to do a PhD, and not just decided to do a PhD, but decided to do it in Canada. Why did that decision come about, and how did that work? Why did you make that decision in the first place? I mean, I'm sure you could have gone into industry and did anything else, yeah.
Yeah, well, I was originally wanted to. I never wanted to pursue a PhD degree, and I wanted to stop at the master's degree and then start a job. But the reason I started PhD, and for two reasons, I decided to do PhD, and then why I came to Canada is another story. But starting a PhD for me was primarily because during the last few years of my graduate school and undergrad, like the last 2 years of masters, and then 2 years of my masters, and the last 2 years of my undergraduate studies, my mother was diagnosed with cancer, breast cancer, and then it was horrible back then. It was a terrible experience. And then when someone that close to you, you see them that they receive chemotherapy, and then they, literally they lose weight, and then you see them that they suffer from all these treatments, and eventually my mother unfortunately passed away. Then it motivated me to pursue this academic career in which I could somehow make an influence to people's life in a better way, in my opinion, by maybe inventing something back then, or finding a new drug, or helping someone to find a new drug, because that was a very, very I had horrible time back then, observing my mother. And then so what I decided to do was like, okay, so I was doing class. I was in during my master's and bachelor's. I was my field of study was like classical mechanical engineering, and then back then there was no biomedical engineering available and in Iran, or it wasn't that advanced. So I decided to. And then that was a huge shift from classical mechanical engineering to biomedical engineering. Was a huge shift. And I was thinking about where is the best place that I could, I could focus on this field. I could learn more about biomedical engineering, and then also use my knowledge in mechanical engineering, and to develop maybe tools, and then invent something new. So I was introduced to two mentors. I contacted Professor Majid Barami, who is now a professor at Simon Fraser University, and Professor David Sinton, who is now a professor at University of Toronto, but back then he was a professor at University of Victoria. So David Sinton's basically field is in microfluidics, and Professor Bahrami's field is in analytical mechanical engineering, kind of fluid dynamics, basically field. And then they both, so this was like Dr. Sinton was primarily focused on experimental aspects of research, and Dr. Bahrami was like primarily focused on the theoretical aspect of research. So they co-supervised. And then so I started learning about microfluidics in their groups. I started learning about how microfluidics can be used for medicine, how microfluidic can be used, for example, for developing point-of-care devices, diagnostic tools. So that was basically during my entire PhD. I spent a lot of time on understanding mass transport, heat transport, and then also fluid flow within these micro scale kind of systems. So that 4 years, after 4 years, then I learned, and then I learned a lot about this field. And then in my postdoc, then I went and then used this knowledge to develop tools for modeling diseases, which we call them organs in a chip these days, and then also bioprinting tissues for disease modeling, and then also that these disease models can later on be used for, first of all, understanding how the diseases are, like they form and then they develop, and then also they can be used to screen for new drugs or find new targets for existing drugs.
Amazing. So I mean, even though it started out from a not so nice experience, as it were, probably putting it very badly, but it's not a, the motivation really drove you to do something really positive from it, and kind of start to work in this field. And I think that's also something that you're still doing. You were mentioning earlier that you're doing cancer treatment, working with devices and technology that would help cancer patients, for instance, right? So that motivation is continuing, right? So you were living in Iran, and then you decided to do this PhD in Canada. Tell us a little bit about that change of culture, right? Because a lot of the PhD students, for example, or researchers as well, they change their if they're international student, for instance, coming from, let's say, an Asian country or somewhere else, coming to the United Kingdom or to America or to United States, I mean, or to Canada and so on. So the cultural shift is very different, right? From East to the West. How did you experience that? What did you kind of the culture shock that you experienced? Did you experience culture shock, or were you?
I did.
How were you feeling about that?
Did. That's a very important point that you brought up, actually, because for us who immigrate from or who move from those countries, which they have their own culture. For example, in Iran, we have a very different culture than what you see here in like Western countries, right? Even there are some levels of freedom here that you don't see there in Iran. Even these days, the internet speed is different here compared to my country, and there is, like, in Iran, it's more religion oriented, whereas here religion is not the center of everything. So you're coming from a country that even in classes, at least at my time, the relationship between students and supervisors was way different than what you see here.
Right.
Here,
Right.
the relationship, there is more like a friendship kind of relationship. But then in my country, and I bet there's like this is the case in other countries, you see a lot of, hierarchy in terms of, the relationship between the supervisor and then the trainee. And then also there's like different levels of respect. So the trainees always, they respect their supervisor. So there's a lot of difference in that sense. And then also there's even little differences such as food, for example. Food,
Yeah.
even meat in my country, it tastes different than meat here. And
Right.
I thought that it's only me, but when I talk to my wife and then my friends and everyone, they also confirm that there's a different in the taste of the meat that we eat here and there. So these are little things, but as a student who just move from your country and then move to a new country with a new culture, with even a new smell, with new taste in food, everything is different. Everything is different, and coping to this new culture, it takes time. So I've seen many students, my friends, even currently my students, who move from those countries and then they come here with a huge cultural shock, or cultural difference. The cultural shock could even affect their mental health.
Right.
So sometimes they get depressed. Sometimes we had occasionally, I had a friend of mine who even wanted to go back,
Oh.
like 2 weeks after they moved here. And then believe me, I mean, that this first 6 months is the worst time. I mean, for immigrants, it's a time that you need to establish yourself. You need to get used to to settle, get used to the environment, the everything that is different. But then there are always solutions to these challenges, right? There are always ways to make this period shorter. Instead of spending 6 months to 1 year, then there are like ways to mitigate these issues, and then make sure that the time is shorter, and then you recover from this culture shock, and then you start your normal life here. Which, if you want, I can explain those things. But I think this is an important thing. Culture shock. To summarize, those who want to immigrate, pursue a PhD, they have to think about this.
Yes.
They have to consider that there may be some delays in progressing their research, progressing their PhD career or master's career, or whatever career that they're planning to pursue after immigrating to another country. And then they have to accept it, they have to plan for it properly, and they have to talk to those who have experience with these and then learn from them.
Absolutely. And one of the things I found was when I came to United Kingdom first is the language of thinking in my language versus thinking in English, right? So you're kind of translate at the very beginning. You have to kind of translate things in your head to say what does that mean exactly, right? So, and we're talking about like I was my PhD, my undergraduate is in aerospace engineering, so these are very scientific, mechanical terms. There's no real one-to-one translation, so you have to kind of think about it and then kind of make sense in your head, and then it takes a little time to lose that thinking from translating things in your head to thinking in English, right? So you realize, oh, I'm thinking in English now versus whatever other language that you might be thinking you were speaking, right? So it's quite interesting, that change. So you kind of mentioned that you were doing a PhD. How was the PhD experience like when you started? And of course, being an international student, but how was it? Was it what you expected, or how was it different? Was it a good experience or mixed? How was it like?
It was a perfect. It was an exciting. I mean, For me, it was very good. I mean, because I was lucky, I had two amazing mentors, right? I mean, it depends on the mentor and then also how supportive they are. And then fortunately, all my mentors up to like now, they've been really supportive, including those who were my PhD supervisors, both of them, Majid and David, both. So I had a very good experience. It was very different than doing PhD in my home country back then, because in Iran, because of like due to several reasons, which I don't want to get into those reasons, researchers primarily focus on theoretical kind of research, modeling, numerical modeling, analytical modeling, and things of that nature. Whereas here, the focus is more on the application and the applied side of things, and then you gain hands-on experience. You learn how to make these microfluidic, for example, devices, how to manipulate flow in them, how to visualize things under microscope. So this is, in a sense, it was a good experience because what I learned during my PhD complemented what I learned during my master's and bachelor. So that's one thing. And then, but it has its ups and downs too, right? I mean, during PhD, I mean, the problem is that you don't have the experience of a researcher that much, and then sometimes when you fail, you get really upset, right?
Yes.
But because you still don't know that failure is part of the process. I think that was the case for me. So failure is part of the process. You just need to learn how to deal with the failure and then learn from it. That's the thing, and it takes time. So that's something that it takes time. And as a PhD student, if I trusted my mentors, and then that trust helped me to learn from my mistakes, because I trusted them that their advice would help me, and it helped me, right? And then I listened to what they said, and then of course I had my own goals, and then I learned from them, but I mean, I changed things like if needed, but overall, I think trusting a supervisor, learning from them, and then having good colleagues, peers who can also give you advice, it was very helpful for me. I had a good friend of mine. We were roommates for at least 1 year, and then he's now a professor at the University of Connecticut, and I learned a lot from him, how to apply for positions, postdoc positions, for for awards and so on and so forth, and even how to write papers. So it was a good experience, good mentors, good peers. They all helped me to have a fantastic experience during my PhD.
Absolutely, and that's what the importance of having a PhD supervisor that is so supportive of you, right? And I don't know, I've seen in many, if you go into Twitter, and you can kind of see some students complaining about the supervisor not being supportive, and this can happen in any work environment, right? I mean, this is nothing to do with PhD, just PhD, but in a very unique way, it's because you're still learning what's happening, and what you mentioned about failure is also not really kind of part of you kind of haven't really realized what that means. You kind of take, there's a lot of pressure that you put on yourself, right? Which is kind of maybe if you don't really have a check on that, somebody to help you with that, somebody to say, it's all cool, let's get through this, I will help you, then that kind of put a lot of mental strain on people, I think, students especially. So which is really important that supervisors are helping the PhD students, right? So that's really important. So and so you finished your PhD, and you wanted to you had to decide as to whether to, I suspect, to go into industry or continue being in the academia. And you decided, that's it. I love academia. I'm going to go in there. How did that work, and why did you make that decision?
That's again another very very important question that I usually add. Like, I even ask my students, like, when they start their career, like their program in my group, is that what do you want to do with your life? And then and honestly, most of them, and including me myself, when I was a PhD student, I did not know. I was not sure. I just wanted to be honest that I was not sure whether I wanted to go to academia or industry. What I knew was I wanted to start my own business.
Right.
So I wanted to start a company based on, like, ideally something that I would develop during my PhD or postdoc, and then bring that into market. And then, I thought back then, and I still think that this makes a huge impact on people's life. So ideally for me, an ideal job for a PhD student would be a startup, which would be very successful. That's what I think. But back then, I did not have the courage to start a company. I didn't feel confident that I could do that, but I thought that the academic job would help me to achieve this goal. So that was one of the reasons that I selected an academic, career. As I said, my mother was a teacher, and and she was training, little kids, and then, like, helping them to learn stuff. And then back then, she inspired me to find a job that in which I can at least train some, like, next generation professionals. Not many, probably, but at least I can train students who can be successful in their future career. So that was my second motivation to start a position in academia. And the third one was, I knew, and after talking to a few of my colleagues, and then after doing a PhD, you kind of know that, I mean, the academic environment is more flexible in terms of discovering new ideas as compared to, like, an industrial setting. And I always wanted to have, first of all, have multiple projects, and then and work on multiple projects, and then work on multiple ideas. But I want these ideas to be groundbreaking to some extent. And then I felt that in academia, you have a chance to follow these ideas, because the fundings and then the money that comes into academia is, to some extent, is basically designed to be used for discovering new ideas and inventing new things. Although this is not always the case even in industry, you can find, like, R&D, for example, jobs that allow you to discover new ideas. But in industry, you're fairly limited in just
Absolutely.
what kind of ideas you can work on.
That makes a lot of sense, right? So that decision is really, if you're a PhD student, once you finish your PhD, it's really about what drives you and what is your motivation. Really being honest with yourself and really asking the question, what do you want to do, and what's the next step. And it's okay, you can choose the path of becoming a academic or postdoc, and then after that you can go into industry, or maybe do both. You can do consulting, and there's a lot of options available, right? So that's a important idea. And as you mentioned, you can always have a spin-off or a company that based on your work. So before we get into the next kind of section of the podcast, I would like to kind of take a little break and ask you about so one of the questions that we always ask from all our guests is the books that really made a difference in their life, or something that really captured them in a positive way. So please tell us, Professor, what is kind of your first book that you have chosen that might be had made a really good impact on your life?
Well, I mean, the first book, that one of the books, which was the first book that I read, and as maybe it's not related to what I do. It's a novel that I read. It was
Right.
most people may know that. I mean, the Three Musketeers is the first,
Yes.
and then I love that book for many reasons. But one of the main reasons is that it took me from my country to another country, because it was so well written that I could imagine living in Paris, and then look with these,
Yeah.
like, moving around the city. And then that's because and then when after I read that book, I really became interested in
Right.
traveling around the world. And then one of the first cities that I visited after I like I started my PhD was Paris. And I was just picturing myself. I mean, I was going to the Eiffel Tower, to the scene, and then like all different parts of the city. And then I was, remembering what was written in that book. So in that sense, that impacted my life in a way
Yeah.
that it made me like want to travel a lot.
Absolutely.
But I think this is something that those who haven't read this book,
Yeah, definitely. It's an amazing book, actually. I know what you mean when you say that, because it kind of transforms, your imagination, and you can kind of visit
yeah,
these places, right? So when I first arrived in London, I don't know, 20 something years ago, I'm a huge fan of Sherlock Holmes. So I would there are these adventures, in this street, and goes to this other street, or you know I kind of walked around London looking for these streets, right? Which is kind of a very weird thing to do, but I did that, which was, I was like, I don't know, 17 or 18 or something like that. But I was really interested, see all these things. So it was quite interesting. I know exactly what you mean, that imagination and the transporting yourself to a different place, right? So going back to our conversation, so you have kind of had a huge impact on in your research field, and you've done a lot of work in microfluidics, and you have been cited many times, so many times, and it's amazing. So if you were to look back now, are you happy with the decisions you have made so far, and what are the regrets that you might have in your journey, and what are the lessons, or what are the things that you may have done differently?
yeah, definitely I have regrets. I mean, I think if I had this experience that I have right now, like maybe when I started my PhD, I would do some things at least differently. Uh, so so one of the things that I would do differently was that I would focus more on developing a platform during my PhD, uh, which basically I could use that platform later on. I could capitalize on that platform, and then, eventually develop a technology that could help me to start a company, and then, bring it into market, and then make something that's would maybe be used by people right now. So that's one regret that I had, and then that's one thing that I keep telling my PhD students is that, in my opinion, uh, in my field and in my opinion, again, fields are different, but in biomedical field, in the fields that people like researchers are working on tissue engineering, and then microfluidics, and organs and a chip, and so on and so forth. It's always, and it's ideal to have a platform, to develop a platform during a PhD. So you spend a lot of time during your PhD to develop a platform. It could be a platform material, it could be a device, it doesn't matter, but develop a platform that is unique, that solves a problem, and then preferably that solves a big problem that impacts more people, and then just pursue that idea, and then develop it further during your maybe postdoc, and then eventually when you start your own independent you know career as a professor, for example, or start a company eventually. So that's one thing that I would do differently. And another thing that I always, again, tell my postdoc especially is that I would write more grants. If someone wants to pursue an academic career, your life depends, your career depends on life, but your career depends on how well you can write grants. And it's very important for you, like for someone like me, to think about, to generate ideas that is acceptable by peers, and then to write it in a way that is, easy to understand by a committee of researchers with different backgrounds, who have like a little time to read your grant and understand it. So that's the thing that one would only learn by practice. And during postdoc, like when I was in Ali Kadam Hosseini's group, I had this opportunity to write many grants, but I didn't take that opportunity. I just wrote like 2 or 3 grants. And if I go back to my postdoc career, I would write many grants. I wouldn't sleep. I wouldn't go on vacation. I wouldn't party. I wouldn't, relax during weekends, and I would just write grants, because that would have helped me a lot during my career. And then, but other than those, I think there are like some little things that I would do differently.
Yeah.
But these are the major things that I think.
Absolutely. I mean, to without funding, there is not much, you can do, a researcher, right? So it's just how this works, right? So, and it definitely needs practice. It definitely needs quite a lot of thought and attention, right? To convince people to give you money. And this is how this would work even in industry, or if you're starting a company, if you want to apply for funding, apply for venture capital funding and things like that, you would need to convince people that what you're trying to say or what you're trying to do is worth investing in, and that definitely need practice, right? So that's a very good point. So going back to the idea of writing grants, and this is a problem that money is a problem in research, right? So it's the biggest problem probably. So at this moment in time, there are a lot of problems that we see, especially in the United Kingdom, in Europe, and maybe in the United States and Canada as well, and in all over the world. The amount of money that might be available for research, and how that gets distributed, what are the conditions. It's a bit of a how it I'm not 100% sure from talking to people that the amount of time that researchers have to spend doing things that are not research is increasing, every year, it seems, right? So you spend more time doing admin work compared to doing actual research, which I guess is a part of thing, but it has to have a balance. Now, going back to the idea of what are the problems in research, as a professor who have had many experiences working with many different areas and colleagues, what are some of the problems that you see right now in research, and how can we kind of, as a society, help to alleviate some of those problems?
Well, I mean, you mentioned funding. Funding is a major challenge in academia. The problem with academic research is that, because there's not much funding available. The success rates for many grants that we apply is in the order of like 10 to 15%. So right. It means that 1 out of, let's say, out of 10 grants, 1 out of 8 grants just gets accepted, right? Acceptance. So they get funding, but the rest, which are brilliant ideas, and I sit on panels, grant panels, and then you won't believe that you receive many grants with brilliant ideas, and unfortunately you can't fund them. So if it was me, I would just fund all of them, because they're very excellent ideas. But the problem is lack of funding, and then that's partly because justifying spending money, taxpayers' money, on something that may not have an obvious outcome is very difficult for those
Yes.
who support these, granting agencies. But one thing like uh, governments, policymakers, and those who provide funding should know, and they probably know, but again, it has to be, accepted by the general public as well, is that this money does not go to waste, uh, because not all the funding or money that you spend on research goes into developing a product that can be useful. It also goes into training next generation professionals that eventually will go back to society, and then, help others, or like create jobs, or even work in companies, and then, and then help the society to some extent, right? So that's one thing that is the outcome of these, basically, these money being spent in academia. And then the other outcome is, and the other fact is that what we do in research is high risk.
Yes.
So we're working on ideas. Sometimes we're discovering ideas, and some of them, or maybe most of them, they may not lead to a product, but it generates knowledge that you can build on, the knowledge that gradually generates within the community, and eventually that knowledge will help one researcher or to develop, or a group of researchers to find a solution to a major problem in in society. For example, for example, these devices that were built for detecting, or for example, in the case of vaccine, right, COVID vaccine, it was not like an overnight discovery, right? There is a few decades of history, at least 2-3 decades of research and development put into making these little vaccine carriers, these mRNA carriers. There are a bunch of companies, many researchers, they work on this topic until this COVID vaccine was developed, and then it was, for example, by Moderna, right? And it was used to help the society during this, crisis, right? So the general public, they have to understand that, there is, but training this next generation, generating this knowledge, it costs the taxpayers, right? And then it costs money, and then it's a money that has to be spent, so that we can generate new things. So that's a challenge in terms of funding. But there are some specific challenges. There are some challenges that are specific to my field as well. So I'm what I do is biomedical engineering, and biomedical engineering is at the interface of multiple disciplines: biology, engineering, mechanical engineering, material engineering, electrical engineering, and then also microbiologists and biochemists and chemistry in general. And then we also have to work with clinicians as well. So you see that each of these disciplines, they have their own languages, right? And then being able to communicate with colleagues in different disciplines, and first understand each other, is a problem, and then also being able to even work with each other with the same pace is challenging these days. And then, for example, those who work in biology, biology by itself, it's a slow process. Learning how cells work, how cells respond to for example, different drugs or different compounds, it takes much longer time than, for example, us as engineers making a device, right? For example, using a milling machine. So for us, it's a matter of a few days. For them, it's a matter of a few weeks or months, right? And for them, it's more expensive. For us, it's less expensive. So it's an understanding of how research, is done in different disciplines, and then working together to, like to develop things all together is a challenge that that we're trying to overcome, but it is still a challenge, right? And then eventually it will be solved by talking to each other, by communicating more. But still, it's a challenge that we are facing at this stage. And then also there's you know sometimes in terms of trainees is uh, I mean, you're dealing with trainees that they don't have enough motivation to do, for example, a PhD or a master for several reasons, and then also, or maybe their goals are way different than the goals of that are expected from them. You know, because each, for example, researcher has a different goal, but there is this mismatch between the goals of the trainees and the PI, the principal investigator who runs a lab, for example, which can be mitigated only by communication. Yes. So what I do typically at the beginning of when I talk to interview trainees who want to join my lab is I ask about their motivation, what they want to do, and going back to the future goals, is what they want to do with their life after graduating. And then I ask this because of several reasons. The first reason is because I want to adjust my training, methodology, because it's different. I mean, my training method is different if I want to, to help a student who wants to pursue like an industry career, as compared to those who want to become to join academia. Papers are more important if you want to join academia. Grant writing are more important. Whereas if you want to pursue an industrial job career in the future, then you need to learn techniques, and then like papers are not that important. Again, these are like the differences sometimes. So, but even after you talk to the students, to talk to the trainees, and then lay out all the expectations, still you don't see that motivation. And I heard from many of my colleagues that this is the case. And then that lack of motivation is something that that sometimes creates misunderstandings between the supervisors and then the trainees, and then sometimes generates frictions, and then make this whole master's or PhD program something that is not satisfactory for both sides, right? So that's another challenge that I face. And then of course, I mean, you mentioned some also the workload as well in academia. I mean, yes, administrative workload is sometimes too much for colleagues, and then for all of us, especially when you reach like after your tenure and then you start your associate professorship and then become a professor, then there's a lot of administrative stuff that you have to take care of, and then and some but other than that, it's not a big challenge to me, at least, because I see that as part of my job, so I have to do it.
Absolutely, absolutely. And thank you. That was I mean, as a professor, you have many hats to wear, as it were. And of course, in your case, it's not just being a professor, but also being a entrepreneur, which is a kind of much more. There are synergies between the two things, but also they are very different as well, right? So, if you want to give for a PhD student or postdoc or anybody who hasn't got to the level you have, what is the one piece of advice that you might want to give them?
Well, the only piece of advice that I can give them, which is very, it's a very difficult decision to make, and I don't have, it's a personal thing, is to decide what they want to do with their life. And I think, for a PhD student, it's a little bit difficult, but for a postdoc, it should be very clear. When they start their postdoc career, is that they have to have a clear vision of what they want to do with their future career. Because but PhD students, I advise them to start thinking about, their future, because, and don't leave things to the last minute, because then you will not have, your choices will be limited. So but if you, for example, if a PhD student knows what they want to do, and again, all these three paths, academia, entrepreneurship, or industry, they're good for like, it depends, it's a completely personal decision. But if it's better to decide which path they want to take, right, before, like, during the first 2 years of PhD. It's because it will help them to shape their CV, and then and learn things that are more relevant to their future career.
Absolutely.
That they envision. So that's something that I would ask them to definitely think about.
Start thinking about that as early as possible, right?
As early as possible.
So we are kind of coming to the end of our conversation. So, it has been really interesting and really great. So I want to kind of talk about a little bit about your future plans. And, I know you're working on many things. And you mentioned that the companies that you're working on as well as being, as an academic. Please tell us a little bit about the projects that you're working on and the future projects that you might be working on as well.
Yeah, definitely. So my lab is, just if I wanted to mention what I do in my lab, what we do in my lab, and what our vision is that we are trying to create practical solutions to restore and enhance health of individuals. So we try to invent solutions that could be used, or that could be tailored towards individuals' needs, so personalized healthcare. And so we use micro nanotechnologies to create personalized solutions to some of the grand challenges in health. So my lab focuses on three major areas. So one major area is material development, and we use these new materials to deliver drugs to the site of the disease. In particular, we are focused on cancer treatment, and for the reasons that I mentioned at the beginning of this podcast, and then in particularly for over the past few years, we've been focused on glioblastoma, which is a brain tumor, the deadliest type of primary brain tumor. Like, there's only one drug available for that type of cancer, and then the survival rate is around 1 year. And then there's a dire need to develop new therapeutics, and also find ways to deliver drugs to the brain, because brain is as an organ, it has some barriers against drug delivery that makes it very difficult to deliver drugs by, for example, injecting them into the bloodstream, right? So we're working on that, and then we're creating these new materials and new drug delivery systems for treating cancer in general, and glioblastoma, brain cancer in particular, in my lab. So we're pursuing that route, and then we're now working on incorporating 3D printing into the workflow and to the standard of care, and because of that, we've developed this basically new handheld, we call them printer, that can be used at the point of care by the surgeons, So when they remove the tumor, then they can use this pen to directly print basically drugs which are loaded into these viscous materials directly into the site of the injury, into the site of the tumor after the tumor is removed, and then the drugs will slowly remove or slowly released from these materials, and then they go penetrate deep into the brain and then reach to the cancer cells that have infiltrated into the brain, and then hopefully we can kill those cells and improve the quality of life of these patients and then their survival rate. So that's one thing. And another part of my research is focused on developing disease models, and then in that sense we're focused on cancer, ovarian cancer, pancreatic cancer, and then mostly on glioblastoma. So we have developed a microfluidic model of glioblastoma, and the reason we are interested in developing and using microfluidics for that application is because microfluidics allows us to use very smaller amounts of reagents and drugs, and this will reduce, hopefully in the future, will reduce the costs associated with screening thousands of drug compounds during the drug development process. And also this microfluidic system enables us to perform tests in parallel at a much lower cost, using minimum footprint, reducing footprint, and then without need to have like a lot of big spaces for growing cells and then testing drugs. So that's why we are interested in using microfluidics. And so far we've been able to make this glioblastoma model on a chip, we call it, that recapitulates the genetic and proteomic levels of the human glioblastoma. And then the next stage for us is now to add more complexity to the model. For example, we know that in the brain, one of the major barriers against the transport of drug from blood vessels to the tumor is the blood-brain barrier, which basically is designed to protect the brain from external objects, right? But now that we want to deliver drugs, then we want to be able to cross this blood-brain barrier so that the drug can penetrate into the brain and then reach the cancer cells. So now we want to model this blood-brain barrier or add this blood-brain barrier to the brain, but this blood-brain barrier should mimic the blood-brain barrier that you see in the or the vascular system that you see in the tumor, which is different than healthy tissues. So there are some challenges there that we need to overcome. So that's another aspect of my research. And then the third part of my research is focused on using these novel materials to develop platforms for continuous health monitoring. So we're focused on wound care and on chronic wounds. And believe it or not, chronic wound care has, the process of monitoring wounds has not changed for decades. Right. It's like you go and see a doctor, and then the doctor removes the dressing, looks at the wounds, smells it, look for signs of infection, and then just cleans the wound and closes the wound, and then sends the patient back home. And then if the patient has symptoms, then they go back. Otherwise, they have to regularly visit their doctor. So there's always this challenge of visiting doctors regularly. And this is not always the case for example, elderly who cannot, who have mobility issues, those who have, for example, a spinal cord injury, those who live in remote areas, which they can't travel a few hours to find this specialized clinic. So what we're trying to develop is a wound dressing that has sensors in them, in it, and then these sensors, they send signals, or they alert the caregivers or the doctors wirelessly that the wound has become infected or the wound needs attention. And that's the part that we're working on at the moment. So we've developed a couple of sensor-enabled wound dressings, and then now we're working on the next steps, which is basically adding more complexities to the existing sensing platforms to not only detect, for example, infections, but also to identify the type of pathogens that are present in the wound, because it's very important to know what kind of bacteria or microorganisms are present in the wounds, because it will help the doctors to prescribe a more targeted antibiotics. Otherwise, the doctors will just prescribe a broad spectrum antibiotic, which can cause this antibiotic resistance and then eventually cause issues to the patient. So these are basically the three main areas that we're working on. Recently, we started looking into another area, which is called cell manufacturing, which is a huge challenge right now for regenerative medicine. So for those who are not familiar with regenerative medicine, using cell therapy approaches. So what this approach does is uses like cells collected from patients, for example, a small biopsy, and then expanding these cells, which means that make billions of cells out of like thousands of cells that you collect from patients, and then grow these cells and then inject them back into the body, into the injured site. So these cells go into the site of injury, they're remodeled, and they start produce, for example, proteins that have healing properties. But the process of making millions to billions of cells from only thousands of cells is challenging these days. So, and we're trying to address those challenges by using new materials and the new methods that enable us to use, for example, the third dimensions of the three-dimensional environments that enable us to create more cells. So that's another topic that we have recently started working on, and it has huge applications not only in cell therapy but also in, for example, in these exotic applications such as cultivated meat, and then also vaccine generation, and so on and so forth.
That's incredible. I mean, that just sounds so, I can't even explain how cool that sounds, right? It sounds incredible, and, almost, and they are so practical and so useful explanation as well, right? So I can really understand that. If anybody wanted to contact you, how would they be able to do that, Professor?
So there are different ways to contact me. My email address is, like, they can email me for sure. I'm on LinkedIn, so if they Google Mohsen Akbari, then they can find me on LinkedIn. And I'm also fairly active on Twitter. So my Twitter handle is Lime, LIME _ Akbari, my last name. Lime is the name of my lab, basically. So they can find me on Twitter as well. I'm fairly active on also LinkedIn, and emails is also, as I mentioned, makbari@uvic.ca is my email.
All the details will be available in the show notes as well. And the final question, just to kind of come back to the way that the journey that you have taken so far, and the amount of contribution you have provided, not just to the scientific community, but into the population as a whole. If you wanted to thank someone that helped you in this journey, and maybe you didn't have the chance to do so, or if it's just at this moment in time you wanted to do that, who would that be, and what would the message would be to thank someone?
Well, I can't thank just one person, honestly.
Yeah.
I mean, that's for sure. I mean, my mother and father, of course, they helped me a lot. But my mentors, I'd like to always mention their name in a book. I mentioned their name in all my talks, because without them, I wouldn't be able to do to achieve anything that I have achieved so far is like my undergrad Bijan Farhanieh, and then my master's degree mentor, who was an amazing mentor, Majid Barami and David Sinton, both of them doing PhD, Ali Kadam Hosseini and David Yanker at McGill and Harvard Medical School. They're like these people collectively helped me a lot, and then they made me grow over this few years. And now that I'm started my career as an independent researcher, that I've been here like doing like having my own research group, is even believe it or not, I mean I think my students, my trainees have been instrumental in my lab. I have learned a lot from them over the past 7-8 years. That you won't believe it, that they've been teaching me things that I have never thought about. And then also my colleague here at University of Victoria are like these are amazing colleagues that one would expect to have. So I think I can't mention one name, but I'd like to appreciate the support and help of all of these colleagues that I had so far, from my master's and undergrad when I was in Iran up until now.
Absolutely. Thank you for that. And just to end our conversation, Professor, please tell us another book that you feel that may have affected your life, and something that you absolutely loved. It doesn't have to be anything academic. It could be something that you just loved.
Yeah, sure. So I haven't finished this book yet, but I have started a book that is basically related to critical thinking, and then the art of thinking clearly is a book that I have started reading about, right? That helps you to think properly, and then to use this, the properly think about different challenges and the new stuff. And again, but since I just started reading that book, I think I can't really advise people to read it, but maybe in the future, then yeah.
No, absolutely. We will include that in the show notes as well. And I just wanted to say, Professor, it has been absolutely delightful to talk to you. You have done amazing things, and so thank you so very much for everything that you've done. And I hope that you continue to do and develop amazing things that in the future. So thank you so very much for your time. I really appreciate it, and hope to speak to you again soon.
Thank you very much, Serge, for again inviting me. I think this is an amazing thing that you're doing, and then keep doing a great job. Take care.